Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello everyone, I'm John, a math teacher. This time I'm with senior 5 students in our unit 5, solving equations by numerical methods. You remember what we did concerning linear interpolation and extrapolation, also location of root by analytical method, right? Now, we have another method, but before dealing with that method, let us make quite a revision. So please get your calculators and exercise book and work out this exercise. Let f of x equals ln of x minus 2 power x plus 3. Show that the equation f of x equals 0 has two roots, alpha and beta, such that 0.01 is less than alpha less than 1, and 1.5 is less than beta less than 2. Means that you have to show that there is a root between 0.01 and 1, also another root between 1.5 and 2. I'll give you just a minute to finish that activity. Go on. Are you ready? Okay, just a few seconds. All right, hope you are ready now. Follow on chalkboard because they want to make the correction on chalkboard. Remember that when you have your function, f of x, and you have your interval, maybe from A up to B, if f of A times f of B is negative, it means either f of A can be positive, f of B can be negative, or f of B can be positive. If A is negative, then the product will be negative. Of course, you raise the change of sign between these two values, then you conclude that there is a root, isn't it? So here we have our function is there. F of x is equal to ln of x minus 2 power x plus 3. And we have 0.01 is less than alpha, less than 1. Are we together? So it means that we have to calculate f of 0.01, f of 1, and we compare if there is change of sign, and we conclude. You have your calculator. Mine is here. When I calculate, I get minus 0.6, and there you have 0, 3 minus 2, that is 1. Already this is negative, this is positive, right? Yeah, there is change of sign. Also, the function is continuous. Therefore, there is a root between 0.01 and 1. Means that 0.01 is less than alpha, less than 1. Are we together? Nice. Then for the other root, we have to calculate f of 1.5 and f of 2. You calculate I get 0.577, and for 2, minus 2, so 8 plus 3, minus 0.9. Let me verify. 3 minus 2 squared plus ln of 2, minus 0.3. Also, there is a change of sign, means that there is a root, our root is beta, between 1.5 and 2, and you are done. All your answers similar to these ones? Oh, very nice. Now, the method has been understood. Now, we need to do the same, but using a new method. Locating roots by graphical method. Dear students, if I try to solve that equation, ln of x minus 2x plus 3 equals 0, solving this equation is not easy. I can try, but at a certain level, I'll be stuck. So, and other method I'm thinking about, things can get messy, so it is not easy to solve that. However, as mathematicians, we can fail. We can't. So we think about a new method, and that method is the graphical one. So how that method works? Method. First of all, you have to write our equation f of x equals 0. 2, rewrite f of x as f of x, capital, equals capital G of x, right? Then, sketch the graphs of f of x and G of x in the same diagram. Here I mean in Cartesian plane. Again, if y equals f of x and y equals G of x intersect at n points, then our equation f of x equals 0 has n roots. That is the method, right? So let us try this equation, which was very difficult to solve by algebraic method, then using the graphical method to see if it can work. Example, find the root of equation ln of x minus 2 power x plus 3 equals 0. Are we together? Follow on the chalkboard. The first step is to write the equation like that. So, means that f of x equals 0 means that ln of x minus 2 power x plus 3 is equal to 0. Then write f of x as f. Capital F of x equals capital G of x. Means that you are going to solve. I can have ln of x minus 2x plus 3 equals 0. Moving this to the right-hand side, this can be written like ln of x equals 2 plus 3 equals 2 power x. But also I can take 3 minus 2 power x equals ln of x, thing like that. It can work also. So if you realize here, this can be taken as y equals capital F of x, and this is capital G of x. Already I have my two functions, f of x and g of x, right? Then I'm going to sketch on the same Cartesian plane these two functions. They take y equals f of x, means that y is equal to ln of x plus 3. Get your calculators, work together for different values of x and y. 0, 1, 2. Please get your calculators. You can even add the 3. You have your calculators, you work together. For n, 0, we know ln of x is negative infinity. Negative infinity plus 3 is still negative infinity, right? Then ln of 1 is 0. Then plus 3, here it will be 3. Then for 2, I get a 3.7. It's an approximation. And when you calculate for x equals 3, you get 4. Approximation, right? And then for y equals 2 power x, xy, taking 0, this will be 1, 2 power 0 equal to 1. Then 1, 2 power 1 is 2. If x equals 2, this will be 2 power 2 is 4. Okay. Now we are going to sketch these two curves. Hope we are together. 1, 2, 3, 4. Minus 1. Minus 1, minus 2. 1, 2, 3, 4, and so on. X-axis, y-axis, 0, 1, 2, 3, 4. Negative 1, 1, 2, 3, 4, neg 1, neg 2, and so on. Then my function is increasing from negative infinity down there, passing through 1 and 3, 1, 3, then 2, 3.7, then 3 and 4. Are we together? And the graph looks like this. This is y equals ln of x plus 3. And there we have also 0, 1 is there. 1 and 2, 1, 2. Also 2 and 4. The curve looks like this. Do you see? This is 2 power x. My two curves intersect at this point and this one, isn't it? Then the x-intercept of this intersection are the required roots. Means that if this is alpha, that is the root, the other root is there. Realize that the root is close to 2, and the root also is between 0 and 1. So as two curves cross twice, since y equals 2 power x and y is equal to ln of x plus 3 cross twice, the equation ln, well, is it ln of x minus 2 power x plus 3 equals 0 has 2 roots. Is it difficult? Is it difficult? Not at all. The answer is there. Now, let us have an example for you using the same method. And you can take just 1 minute to write this example, thinking to the new exercise. Are you done? You have few seconds. And we jump on that activity. Okay, hope you are done. We are here. We have our equation. Means that this is our f of x, right? F of x equals x cubed plus 2x plus 1 equals 0. As the method says, we have to write f of x is equal to 0, means that x cubed plus 2x plus 1 equals 0. Then we have to write this equation as the equality of two other functions. So it means we can have x cubed which is equal to minus 2x minus 1. Already, the right-hand side, I have a linear function. So this can be taken as y is equal to capital G of x, and x cubed is capital F of x already. And as we did before, we are going to sketch or to draw the curves of these two functions in the same Cartesian plane, and we see whether those curves can cross, can intersect or not. Using the table, x and the corresponding value, y. If I take x to be 0, I'll be having 0, of course. Remember, we are working with this function, x cubed. If x equals 1, y will be equal to 1. If x equals minus 1, I'll be having also minus 1. For the other function, y equals minus 2x minus 1, x and y, taking x to be 0. If x equals 0, y will be equal to minus 1. If x equals 1, I'll be having minus 3. Even taking y equals 0, I'll be having -1/2 and 0. So it is a straight line. Even 2 points are enough to sketch a straight line. Let me use this space. Follow carefully on chalkboard. These axes should be perpendicular of each other. Yes, this is my x-axis, y-axis. Then, this is the origin, put 1, 2, 3. Make sure we take the same units on x-axis and the y-axis. 1, 2, 3, and so on. -1, -2, and so on. We have a 1 and 1, -1 and 1. -1/2 is there, and 0. Even we have also -1 and -1, so the curve looks like this is y equals x cubed. This is the odd function. The origin is the center of symmetry. Then the other function, we have 0, -1 is this point, and 1, -3, 1, -3 down there, but we can join this and join these 2 points because they are enough for the straight line. Do you see? This is y equals minus 2x minus 1. My two curves intersect at these points. Isn't it? And of course, here we have -1/2. So the x-intercept should be at this level. Let's call it x0. So as my two curves cross once, we have one root. since y equals x cubed and y equals minus 2x minus 1 cross once, our equation f of x equals 0 has one root. And the rest that nega half is less than x naught, less than 0, is lying between nega half and 0. Is that difficult? I think no. It's very simple. Okay? Let me give you a homework. Of course, you are going to work out these exercises using the graphical method. Even if possible, you can try the analytical method to see if the answer will be the same. But when you get stuck, please think about the graphical method, which is very simple. So the homework, use the graphical method to find and locate the number of roots of the equations. The equations are follow. ln of x minus 3 raised to power 2 equals 0. 2 e power 2x plus x squared equals 3. Number 3, x cubed minus x squared minus 9 equals 0. Number 4, x cubed minus 5x plus 1 equals 0. 5, x cubed plus ln of x minus 2 equals 0. 6, x cubed minus 7x minus 2 equals 0. And the last, you have a 2x minus 1 over x equals 0. I think the homework is very clear and it is very simple. Whether you get time, you can also try this one. As your auto-evaluation, try this one. F of x equals x plus minus x plus 3. You can try even this one. And see whether there is a root or not. Remember, when you find the intersection between two curves, the x coordinate of that point of intersection is the required root. Thank you very much for your attention and participation. I hope to meet you next time. I wish you all the best. Bye-bye.